PBR Automotive Proprietary Limited would like to welcome you to this brake diagnostic video. In this video we shall explore the problem of low brake pedal and discuss probable causes and rectification procedures. A low brake pedal may be defined as one which can be depressed more than half its total travel and may in some cases be accompanied with a loss of braking performance. Irrespective of whether a loss of performance occurs, customer perceptions are usually that the two are linked, and the concerns that they express will tend to reflect this. In a previous video, we examined spongy pedals, which also suffered from excessive travel. A low pedal, however, can be easily distinguished because it exhibits one or two additional characteristics that the spongy pedal does not. The first is that whilst the pedal is low, it is still firm, with none of the sponginess of the previous complaint. The second characteristic is that on some systems, rapid pumping of the brake pedal may decrease some of the excessive travel, temporarily bringing the height back to somewhere near normal. The cause of a low brake pedal may be either mechanical, hydraulic, or a combination of the two. Mechanical problems are due to excessive clearance in the brakes, or the pedal and booster assembly. Hydraulic problems, on the other hand, are usually restricted to a circuit failure due to fluid leakage or some internal fault in the master cylinder. No matter what the problem, diagnosis time can be greatly reduced if a logical sequence, such as the one shown on this flowchart, is followed. The first step in any diagnosis procedure is to check that the problem actually exists and is not in fact normal for the type of vehicle being examined. If doubt exists, it is often helpful to perform a comparison with another vehicle of the same type and specification. A comparison can also be of assistance in demonstrating to a concerned customer that the condition is normal for that type of vehicle. Once it's been confirmed that the pedal is indeed low, the next step is to check the fluid level in the master cylinder reservoir. A low fluid level is an indication that a leak may exist in the system, the cause of which must be investigated before proceeding any further. A total loss of fluid in one section of the reservoir would indicate a circuit failure and should have been accompanied by the brake warning light being illuminated. It will, however, still be necessary to visually inspect the master cylinder, service brakes, brake pipes, valves and hoses for signs of fluid leakage. This will allow for the possibility of the master cylinder having been topped up just prior to the vehicle being brought into the workshop. Firstly, check the front of the booster where the master cylinder is attached. A stain, accompanied with peeling paint down the front of the booster, is an indication that the secondary seal in the master cylinder is leaking, or that the front seal of the booster is defective. This allows manifold vacuum to act on the rear of the master cylinder, drawing fluid past the secondary seal and, in some designs, into the booster. Following that, an inspection of the service brake should be carried out for signs of fluid staining around discs and calipers, or drum brake backing plates. Finally, a visual inspection of the brake lines, valves and hoses should be performed, paying particular attention to the flexible hoses and where they're swaged into their steel end fittings. If any of the above-mentioned faults are encountered, they should be repaired before proceeding any further with the diagnosis procedure. If the system passes these initial inspections, the next step is to clamp off all flexible brake lines on the vehicle. This can be done safely and without causing damage to the hoses by using any of the proprietary brake clamps sold by most tool and equipment retailers. The pedal should now be checked for height, and if normal, the fault will lie in the service brakes. If not, the pedal, booster and master cylinder assembly should be checked. Having reached this point, a decision as to which path in the flowchart to take will have to be made. Because service brake problems are more common with low pedal concerns, we shall follow this path first. The procedure is to now release one clamp at a time and check the amount the pedal drops. It is normal for the pedal to drop a small distance due to the design clearance between shoes and drums, or pads and disc rotors. Again, a comparison can be useful in helping confirm a diagnosis, and this can be achieved by reclamping each wheel after it's been tested. In this way, a brake or brakes which have excessive travel will have been easily identified. In a high percentage of cases, it is the rear brakes, particularly those systems which have drum brakes on the rear, which cause problems. Because of this, it is normal practice to release the rear clamp or clamps first. In this way, comparisons between wheels or axles can be easily performed. Let's now spend some time looking at the various problems encountered in service brakes which lead to excessive pedal travel. We shall start by looking at drum brakes. These are still relatively common on the rear of modern small to medium-sized vehicles, and many of the earlier larger-sized ones. Low pedal problems with these types of brakes are caused by excessive clearance between the shoes and drums. This in turn causes the wheel cylinder to move further than it normally would, requiring more fluid from the master cylinder and resulting in longer pedal travel. All modern drum brakes have some form of self-adjusting mechanism, and in many cases no provision in the form of apertures in the backing plates is made for manual adjustment. Even if an aperture is provided, manual adjustment is often difficult to perform, hence the importance of these mechanisms working correctly. Automatic adjusters work in a variety of ways. Some only work when the brakes are firmly applied with the vehicle travelling in reverse, whilst others work when the handbrake is applied. The most common type in use today adjusts whenever the brakes are applied and clearance between the drums and shoes exceeds the designed limit. With the type that only work in reverse, or when the handbrake is applied, the problem may be as simple as the customer not operating the vehicle in a manner which would cause the adjusters to work. Here we have a customer whose house has a circular driveway. He drives in when coming home and drives forward when leaving, never needing to reverse his vehicle. In this case, a simple explanation of how the adjusters work should be all that is necessary to solve the problem. However, self-adjusters can also bind in the threads, or the handbrake cable can be adjusted to a point where the adjusting lever is held away from the adjuster teeth. In some extreme cases, the self-adjusting mechanisms may be prevented from working or have been removed completely by misguided service personnel. Should this be the case, the only long-term solution to the problem is to refit the self-adjusting mechanisms. On vehicles fitted with disc brakes on all four wheels, excessive pedal travel can be caused by a number of mechanical problems. Some of the most common are seized caliper slides or pistons, or excessive wheel bearing free play. The first problem occurs when the pins or slides of a floating caliper or one piston in a fixed head opposed piston caliper become seized. Initially, this has little effect on the pedal height, but as the distance the vehicle travels goes up and consequently the number of brake applications increases, so does the pedal travel. In the case of the floating caliper, the piston applies the inner pad first, and then, because the caliper body can no longer slide, deflects the disc until it contacts the outer pad. Over time, the outer pad is worn down, causing the disc to be deflected further each time before it comes in contact with the outer pad. This naturally results in increased piston movement, making the master cylinder displace more fluid and leading to an increase in pedal travel. With the fixed head opposed piston caliper, the problem is basically the same, except that in this case it is one of the pistons that does not move instead of the caliper body. The result will, however, be the same, and pedal travel will increase as the pads are worn down. Loose wheel bearings, the second problem associated with disc brakes, causes pad knockback and occurs when either front or rear wheel bearings have too much free play. This allows the disc to move an excessive amount laterally, pushing the pads and pistons away from the disc. Again, we are faced with increased travel to bring the pads into full contact with the disc, and again, the master cylinder must displace more fluid. That now completes this path on the flowchart, and we shall now turn our attention to the second path of the chart. This is the path that would have been taken if, after clamping off all the flexible hoses, the brake pedal was still abnormally low. In this section, we shall examine the pedal assembly, booster input rod adjustment, booster output rod adjustment, booster, and master cylinder condition. Pedals and linkage assemblies contain moving parts and, like all others, are subject to wear. Whilst new vehicles should not suffer from this problem, older vehicles which have been in service for some time should have their pedal pivot points and linkages examined for excessive movement. Equally as important is the adjustment of the brake pedal itself. Any additional free play in this area can lead to excessive pedal travel. When checking free play, manufacturer's specifications and adjustment procedures should always be followed. Next, the clearance between the booster output rod and the master cylinder primary piston should be checked. Some boosters have adjustable output rods, while in others the rod is a fixed length. All are designed to place the primary cup on the primary piston in a position that leaves the compensating port just uncovered. Most manufacturers provide some type of gauge to measure this distance. However, in the absence of one of these gauges, it may be possible on non-fast fill master cylinders to drain the primary reservoir. Shine a light down the primary compensating port and have an assistant note the distance the pedal is depressed before the primary cup is seen crossing the compensating port. On systems where adjustment is available, manufacturer's specifications should be followed. On non-adjustable systems, a component mismatch or the use of non-genuine replacement parts will most likely be the cause. Another potential problem area for adjustable and non-adjustable systems is the reaction disc. This is a small rubber disc which sits between the valve assembly and the output push rod inside the booster. Its job is to allow the driver to control the amount of assistance the booster provides. Should this disc have become dislodged and fallen into the bottom of the booster, which could happen if the master cylinder has ever been removed, the output push rod would then move backwards, greatly increasing the distance it would have to move and causing a corresponding increase in pedal travel. Fortunately, this problem is easy to diagnose. All that needs to happen is for the vehicle to be driven at 5 to 10 kilometers per hour and the brakes applied gently. If the reaction disc has fallen out, not only will the pedal be low, but the vehicle will nosedive, similar to the brakes being violently applied. The final test in this path is the master cylinder itself. In the interests of fuel economy, modern braking systems run greater clearances between the pads and disc rotors, giving far less drag than earlier systems. This has resulted in the master cylinder having to displace more fluid. To maintain correct pedal height and effort, the fast fill master cylinder has been introduced on many current vehicles. This master cylinder features a stepped bore on the primary circuit to initially displace a large amount of fluid and therefore maintain pedal height. This extra displacement is controlled by the fast fill valve. The valve opens at a predetermined pressure and redirects the remaining fluid from the large bore into the reservoir. Should this valve fail in the open position, all fluid from the large bore will enter the reservoir, causing the brake pedal to be low. This will be easily detectable due to the increased eruption or turbulence visible in the reservoir as the pedal is first depressed. On either conventional straight bore or fast fill master cylinders, fluid may leak internally between circuits or over primary cups. In most cases, the pressure differential warning switch should sense the difference in pressure between the circuits and illuminate the brake warning light. Both of the problems mentioned will require overhaul or replacement of the defective cylinder. Of course, no brake repair is complete without a thorough road test to check braking performance before returning the vehicle to the customer. This concludes this video on low pedal diagnosis, but before we leave, let's just recap on what we've covered. A low brake pedal is one that travels an abnormal distance and yet still feels firm. In some cases, its height can be increased by rapid pumping. Causes of low brake pedals can be either mechanical, hydraulic, or a combination of the two. Mechanical problems are usually attributed to excessive clearances in service brakes or pedal and booster assemblies. Hydraulic problems, on the other hand, are usually caused by circuit failures due to fluid leakage or internal faults in the master cylinder. If there is doubt that a problem exists, a comparison can be made with the brake pedal height of a known good vehicle of the same make, model and specification. Having established the existence of a problem, the first step is to check the fluid level in the master cylinder reservoir. This could indicate a leak in the system and should be investigated before proceeding any further. A total loss of fluid in one section of the reservoir could indicate a circuit failure and should be accompanied by the brake warning light being illuminated. Even if the reservoir is full in both sections, the entire system should be checked for fluid leaks. This allows for the possibility of the reservoir having been topped up just prior to the vehicle being brought to you. Check should be made of the front of the booster where the master cylinder is attached, the service brakes, the brake lines, and any hydraulic valves that have been fitted to the vehicle. Particular attention should be paid to the flexible lines where they are swaged into their steel end fittings. If any of these faults are present, they must be repaired before proceeding. Following this, all flexible brake lines should be clamped off using proper brake hose clamps. If the brake pedal is found to be high after doing this, the fault will lie in one of the service brakes. The wheel or wheels causing the problem can be identified by releasing one hose clamp at a time and checking the amount the pedal drops. Whilst the pedal should drop a small amount, a large reduction in height will indicate a problem which will need checking. It is most common for low pedal problems to be caused by the rear brakes, especially those systems with drum brakes at the rear, and is the reason why it is usual to release the rear hose clamp first. Excessive clearance between the shoes and brake drums leads to low brake pedals. This is usually caused by self-adjusting mechanisms being either seized, incorrectly adjusted, or having been removed at some stage during the vehicle's life. Disc brakes, on the other hand, may suffer from seized caliper slides and pistons, or excessive free play in both front or rear wheel bearings. With the first condition, the disc is progressively deflected a greater distance as the pads wear, causing the increased pedal travel. Whilst in the second case, of loose wheel bearings, the disc knocks the pads back further than they normally retract. Next, we looked at what problem might exist if after clamping off all the flexible brake lines, the pedal was still low. We first checked the pedal assembly for wear in any of the pivot points, and then followed this with a check of the booster input rod adjustment. Then came a check of the clearance between the booster output rod and the primary piston of the master cylinder. We highlighted the fact that this adjustment was critical in placing the primary cup of the master cylinder in a position that left the compensating port just uncovered. It was explained that some booster output rods are adjustable whilst others are not. This latter type relying on genuine parts of the correct dimensions to provide the correct adjustment. Following this, we looked at the reaction disc, a small rubber disc that sits between the valve and the booster output rod. This small disc's purpose is to allow the driver to control the amount of boost applied to the brakes, and we noted that if it had become dislodged and fallen into the bottom of the booster, then the output push rod would move backwards to take up the clearance, resulting in greatly increased pedal travel. and overly sensitive brakes at low speed. The last component that we looked at was the master cylinder itself. It was seen that, in the interests of fuel economy, brake engineers are designing systems that have virtually no wheel drag. Because of this, fast-fill master cylinders having a stepped bore have been introduced to provide the increased fluid displacement these low-drag systems require. Fluid displacement is controlled by the fast-fill valve, which opens at a preset pressure and directs fluid from the large bore section back into the reservoir. If this valve should fail in the open position, the large bore would cease to be effective, resulting in low brake pedal. Also, on conventional as well as fast-fill master cylinders, internal leakage between circuits or over the primary cups was another cause of low brake pedal problems. This would usually be accompanied by the brake warning light being illuminated. It was stressed that any of these problems would require replacement or a complete overhaul of the master cylinder. PBR Automotive Proprietary Limited hopes this video has been of assistance and suggests that for other braking problems, you refer to the other videos in this series.